Hi everyone, we're going to do graph sketching. The first one we're going to do is polynomials. We're going to determine where the graph is increasing and decreasing, where it's concave upward or downward, inflection points or point, and the relative min and max, and also if it's even or odd. This is a polynomial, and our zeros, that would be where this is 0. So our zeros would be -2 and 3, because that makes that 0. This one has a multiplicity of 2, so that's going to touch the graph and go back down. It doesn't go through the x-axis. Remember, the zeros are just your x-intercepts. And the first thing we want to do is go ahead and FOIL this out. So when we take the derivative, we can. So when you FOIL it out, you get x squared plus 4x plus 4 times x minus 3. You FOIL that out, and you're going to get x cubed plus x squared minus 8x minus 12. Now what this tells us, if you from pre-cal, is that our end behavior represents y equals x cubed. That would mean we're going to start in quadrant 3 and end in quadrant 1. Okay, so now the first thing we want to do is we have our zeros are at -2 and 3. So what we want to do is pick points in these intervals to see what's happening. So this is a 0 and this is a 0. What's happening, say, at -3? So we plug in f of -3 into our x plus 2 squared times x minus 3. And what you're going to get is, when you plug in -3 here and square it, that's going to be positive. And when you plug in -3 in this part, that's going to be negative. So you multiply those two, you're going to get a negative. So all of this over here is going to be negative. Now we can pick another point. Let's pick 0 and try f of 0. When you plug in 0, you get 0 plus 2 squared and 0 minus 3. And that's going to be negative as well. So that's positive, this is negative, and when you multiply the two, you get negative. So all along here, this is going to be -2. That means below the graph. And at 3, when you try 3, we don't want to try 3, let's try 4. That's a 0, so let's try 4. You plug in 4. That's going to be a positive times a positive. That gives you positive. Okay, so we have positive. So the graph's going to be below the graph between -infinity to 3 and above, if this is y equals 0, this is your x line, and above the graph at 3 to infinity. Now, step 2 is we determine if it's even or odd. Most polynomials, when they're complicated, are neither. And basically, you just test by plugging in x into your polynomial. So you f of x, -x, equals -x cubed plus -x squared minus 8 times -x minus 12. So that's going to give you -x cubed plus x squared plus 8x minus 12. So if it was even, we'd get the same equation. So our equation was x cubed plus x squared minus 8x minus 12. So it doesn't match that. If it was odd, it would be the negation of our function, which would be negative x cubed minus x squared minus 8x plus 12. And it doesn't match that either. So that's why it's neither even or odd. Now step 3 is we're going to check for asymptotes. Since it's a polynomial, we're not dividing. It means the domain is all real numbers, so there are no asymptotes, vertical asymptotes. You only get these with rationals, where you can't divide by 0. Alright, and then step 4 is we're going to take the derivative of our function. So again, our function is f of x equals x cubed plus 8, or x squared minus 8x minus 12. So when you take the derivative of this, we're going to get 3x squared plus 2x minus 8. And if you factor this, we're going to get 3x minus 4 and x plus 2. Set this to 0. So our zeros at 4/3 and negative 2. So I'm going to put that on the number line, negative 2 and 4/3. And I'm going to pick numbers and plug it in and see what happens. So when I plug in, I'm going to check the derivative of x at 0, this part right here, and at x equals, so let's try negative 3. When you plug in f of negative 3, we get 13. Well, 13 is a positive number, so I'm going to put positive here. This is our zeros. This is positive in this area. Now when I plug in 0, and at 0, and you're just plugging it in here like we did before, we get negative 8. So here it's going to be negative. And then on this one, I'll plug in f of 2. These should be derivatives. And I get 8. So that's a positive number, so that's going to be positive. Therefore, f is increasing on, so the graph is going to be increasing here, then decreasing, decreasing here, then back to increasing. So that's how it kind of looks. And so this is increasing from negative infinity to negative 2. It's decreasing here from negative 2 to 4/3. And it's back to increasing from 4/3 to infinity. Okay? Now for step 5, we're going to determine if it's concave up or down. So we take the second derivative. The second derivative is going to just be 6x plus 2. And set your x to equal to 0. And so x equals, the zeros would be 1/3, negative 1/3. So I put that there. And then I plug in values here and here. And I'm going to choose f, the second derivative, at negative 1. And I get negative 4. So that's negative in here. This is your 0. And then I'm going to check on the other side. I'll go ahead and check, let's see, 0. That's always a good one. And that equals 2. So that's going to be positive. Therefore, f is concave downward. So this part right here, it's concave downward at negative infinity to negative 1/3, and here it's upward at negative 1/3 to infinity. All right? And f has an inflection point. Your inflection point's right here, so you plug in negative 1/3 at f. So f of negative 1/3. Plug it into your original equation, and you get negative 250 over 27. So our inflection point is at negative 1/3, comma, negative 250 over 27. Okay? Now step 6 is the min and max. So at f of negative 2, we have a 0. And at f of 4/3, we have negative 500 over 27. So by either the first derivative or second derivative test, f takes on a relative minimum of 0 at relative maximum at 0 at negative 2, and a relative minimum of negative 500 over 27 at 4/3. So the last step is to graph it, and I went ahead and graphed it. We already knew that it is increasing from negative infinity to negative 2, and also at the points here. Concave downward would be this part right in here. This is concave downward because it keeps going this way, but all of a sudden at this inflection point, which our inflection point is negative 1/3, comma, negative 250 over 27, it starts, and I didn't graph it that great, going back up through my zeros. Here at negative 2 and 3, I have my relative minimum and my relative maximum. Okay, that's all. Thank you. Have a nice day. Bye-bye.